Hi everyone, welcome to Chemistry 1, where we're talking about compound percent composition, and this video is strictly just going over practice problems, and these problems are going to be on the easier end. I like to do these so that we get comfortable with the work before us in the lecture, so that when it comes time to doing homework assignments, quizzes, and exams, we're not looking like deer in headlights. We're familiar and we are confident in doing the work. So the first example that we're going to do is find the compound percent composition of sodium hydroxide. And the first thing that we have to do is find the molar mass. For the sake of time, I am not going to go over how you find the molar mass. I will link the video that I've done on it below so that you can refer to that. But the molar mass, using the formula from the molecule that is given to us and the periodic table, is 39.998 grams. Now, we use that information and all the elements that we have in the molecular formula to find the percent composition of each element, and we're going to start with sodium. I like to go from left to right. So for sodium, we use the same formula. How many elements of sodium is in the molecule? Only one. So it's going to be 1 times the molar mass of sodium, which is 22.99 grams. That's also from the periodic table. All over 39.998 grams. Then we're going to multiply that by 100. Do the math. That comes out to 57.479%. So this is now something that we can say that sodium makes up 57.479% of sodium hydroxide. Now we'll go to oxygen. Same process. Only one element, only one atom in the whole molecule of oxygen. It has a molar mass of 16 grams. All over 39.998 grams times 100. Doing the math in the calculator brings it to 40.002%. And then for hydrogen, same process. One atom in the molecule times 1.008 grams over 39.998 grams times 100 is equal to 2.520%. And then if we were to do the math, all of this equals 100%. 100%. All right, let's try another example so we can get familiar and more comfortable. Okay, NO3. I'm going to write that the molar mass, once we do what we're supposed to do using the formula and the periodic table, is 101.11 grams. Then we're going to strategically go from left to right and do the same formula for each element. So for potassium, I have 1, since there's only one atom of potassium in the whole molecule, times its molar mass of 39.10 grams, all over 101.11 grams, times 100, and that is equal to 38.671%. Now for nitrogen, 1 times 14.10 grams over 101.11 gram times 100 is going to come out to 13.945%. Now, we can do the oxygen term and find it, but you can also deduce that if you add these two, and if we know that it's all supposed to be it's all supposed to equal to 100%, we can figure this out. So really quick, I'm going to do the math on that. I'm going to add 38.671 plus 13.945, and then subtract that from 100. That supposedly means that, I'm going to put it over here, the balance should be, let me write it down, 47.473%. But I'm going to also do the work. So for oxygen, now we have 3 atoms of oxygen in the molecule. So it's going to be 3 times the molecular weight, the molar mass, which is 16 grams. 101.11 grams times 100. And then when we put that in the calculator, it comes out to 47.473%. And that's what we found with the calculator. So it actually is a good way to check your work. And honestly, to save you time when you're doing your quizzes. If you follow the formulas correctly, you only have to do all but one, and then you can subtract everything you found from 100 to find the last one. All right, and let's do one more. Phosphoric acid. Its molar mass, you will find, is 97.994 grams. Starting with hydrogen, 1 times 1.008 over 97.994 grams. Again, I want you guys to visually connect that we are comparing partial over whole. Whenever you do that, you get a percentage. Times 100%. I'll just put 100. Once we do the math, it comes out to 3.086%. Now we're going to do phosphorus. Per the periodic table, phosphorus has a molar mass of 30.97 grams. Put grams up there too. Divided by 97.994 grams times 100. Doing the math gives us 31.604%. And then last but not least is oxygen. And that is 4 times 16 grams times 97.994 grams times 100 is going to be equal to 65.310%. Then when you do the math, 3.086 plus 31.604 plus 65.310, you end up with 100%. Alrighty, guys. I do have another video where it is more difficult problems. It's coming up right after this one. So follow me over there so we can go over some problems. Now that we have this under our belt and we're feeling more comfortable, we can dedicate ourselves to figuring out some that may be a little bit more difficult, but not impossible.